Hope you all are doing good at home. In the previous session of physics, we discussed on the chapter force and Newton's laws of motion. So there we studied what is a force. A push or pull on any object is called a force or is defined as the force. So force, an external force or force, is required in order to set the object from rest to motion, or to bring any object from the state of motion to the state of rest, in order to change the direction of motion of the object or to change the shape of the object. Here we have listed, force is required to move any object, to change its speed, to change its direction, and to change its shape. All these things, the external force acting on the body matters. So force is required. Any object dropped from this certain height falls towards the earth. So this is the piece of chalk. I will simply drop it. It will fall towards the earth, but I caught it. So whenever you drop any object down, children, drop any object, it will fall towards the earth. Why does it fall towards the earth is the question. So the moon goes around the earth. We all know that moon goes around the earth. We all are fascinated about our solar system. The moon is going around the earth. Why is it going around the earth? All the planets are revolving around the sun. How is it possible? Is sun tying the thread to all the planets and holding together and sitting in the center? No. Then what is present between those planets and the sun, that with what reason are they revolving around the sun? How can moon go around the earth? All these things, if you question yourself, children, we will come to know that some force is present in all the cases. Force is present which is responsible for your motion of the moon around the earth, or for all the planets revolving around the sun. All these things, there is some force which is responsible, and that is nothing but the gravitational force, children. It is the gravitational force. You know the story of how Newton invented the gravitational force. The apple falling on his head, he is sitting down the apple tree. All the story you have learned in your lower classes, no, children? So that is about the gravitational force. The gravitational force of the earth pulls all the objects towards it. So that is the gravitational force. The earth applies gravitational force on all the objects. So in this lesson, we will be studying more about the gravitational force, children. So you have this chapter in page number 131 in your textbook, chapter 10, that is gravitation. Here they have given one activity. So in your textbook, children, we know that the moon goes around the earth. An object, when thrown upwards, reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract the apple, can it not attract the moon? Is this force the same in both the cases? He conjectured that the same type of force is responsible in both the cases. Conjectured means he did a guesswork. He guessed maybe both the forces are same. If the force is applied on the apple by the earth, can it apply on the moon? Can it apply on me? Like this he thought. His guesswork started like that. He argued that at each point of its orbit, the moon falls around the earth instead of going off in a straight line. So it must be attracted by the earth. But do we not really see the moon falling towards the earth? Let us try to understand the motion of the moon by recalling this activity. So you all have done this activity. Tie a thread to a stone and rotate it. And if you leave the thread at some point, it moves tangentially. Means it does not go in circular motion and fall, children, but it falls tangentially. Means in a straight line. What is a tangent? I will tell you. It moves tangentially, we say. It moves tangentially means in some straight line, in some direction it will go and fall. That activity is being given here. Take a piece of thread, tie a small stone at one end, hold the other end of the thread and drill it around as shown. Note the motion of the stone, release the thread. Again note the direction of motion of the stone. Before the thread is released, the stone moves in circular path with certain speed and changes the direction at every point. The change in direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center, and this force is called the centripetal force, means central seeking force. So you know about the centripetal force and the centrifugal force. Centripetal force means from all around the force, if it is getting confined, if it is focusing towards the center, then that force is called the centripetal force, children. Centrifugal means from the center the force is distributed around. That force is the centrifugal force. So this example of tying the stone with the thread and rotating is the example for the centripetal force, which is responsible there from the such a rotational motion, the circular motion what is taking place of the stone is going in some direction due to the centripetal force provided by the thread what you are holding, that is the central seeking force, that is centripetal force. What is centrifugal force means? The best example I can give you is of washing machine. If at all you have seen in the top load especially, or even in the front load, you can observe when you switch on the machine, no children, the cloths will stick on to the walls of the drum or the container of the washing machine. You might have observed this. If not, please observe. Why? Because from the center, the force is spreading all over, so that the walls, the cloths what you have put for washing is sticking onto the walls of the drum of the washing machine. So that is the best example for the centrifugal force. From center, it's spreading around. Centripetal means from around to center, like that. Centripetal force, centrifugal force. In the absence of this force, the stone flies off along a straight line. I said no, this straight line will be a tangent to the circular path. What is a tangent means? You know what is a circle. This is the center point of the circle. If you draw a line to a circle, so that the line touches the circle at only one point, then that line is called a tangent. And you can draw a line here also. The line is touching the center at this point. So this is the tangent. If I draw like this, then this line is the tangent. See, if I draw a line like this, the line is touching the circle at only one point, one and only one point. That is important. Then that is called a tangent. That is what they have defined here. A straight line that meets the circle at one and only one point is called a tangent to the circle. Straight line ABC is a tangent to the circle at point B. That is the tangent. So, the motion of the moon, I think I stopped here. The stone flies off along the straight line. The straight line will be a tangent to the circular path. And what is the tangent? We study. See, the motion of the moon around the earth is due to centripetal force. So the stone tying through a thread, this activity, you just compare it with the motion of the moon around the earth. The earth is providing the centripetal force required for the rotation of the moon around it. The earth is providing the centripetal force, so that the moon is going round the earth, children. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. So what happens? See, unless and until the centripetal force was there, the stone which you have tied to the thread was moving in circular motion. But once you left the thread, there is no more centripetal force acting. So the stone will fly off tangentially like this. Similarly, as long as earth is exhibiting the centripetal force, executing the centripetal force on the moon will go around the earth. Once the earth stops executing applying the centripetal force on the moon, children, the moon also will fly off tangentially. The moon also will fly off tangentially in a straight line. But earth will not do so. So the centripetal force of the earth is responsible for the motion of the moon around the earth. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? Is the question. Have you ever thought of this, children? Now, the apple, when fallen from a tree, will fall towards the earth. Why? Because earth attracted the apple. Not only apple. If I throw this chalk also, the earth will attract the chalk towards it. But is this chalk or the apple attracting the earth towards it? So what should happen then? If I hold a chalk like this, the surface area, the earth should come and stick like this. Is it happening? No. So what we say generally, no, earth is only exerting force on the objects upon the earth, but no other objects are applying the force on the earth. Do you think it is correct, children? That is what we feel. That is what Newton said. What Newton's third law states, for every action there is always an equal and opposite reaction. So now interrelate, how is it possible? So, yes, of course, the apple or this chalk is also executing the earth. Executing the force on the earth. But compared to the size of the earth, the size of the apple or the size of this piece of chalk is negligible. Yes, no? The huge earth size only, where is the size of the apple or piece of chalk to compare? So, the force is negligible. It doesn't mean the force is zero. Of course, all the other objects, they are also applying force on the earth. But compared to the mass or size of the earth, the force applied by any other objects are very less or very negligible. Since the gravitational force of the earth is more compared to the force applied by any other objects. Hence, all the objects gets attracted towards the earth, children. So, let us find what answer they have given. According to the third law of motion, the apple does not attract the earth. But according to second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. Yes, no, F is equal to ma. You have studied how the force, mass and acceleration are related to each other according to Newton's second law of motion. So, thus the mass of an apple is negligibly small compared to that of the earth. That is very important. So, we do not see that the earth moving towards the apple. Extend the same argument for why the earth does not move towards the moon. So, the size of the earth or the force exerted, the centripetal force exerted by the earth is more compared to the force applied by the moon on the earth. Hence, the moon will not fly off tangentially, instead rotate around the earth, children. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and planets. From the above facts, Newton concluded that not only does the earth attract an apple and the moon, but the objects in universe attract each other. This force of attraction between the objects is called the gravitational force. Please underline this definition of gravitational force, children. So what Newton said is, it is not like only one object is applying the force on another. On earth, each and every object is applying force on each other, but the size matters, the amount of force matters. But in general statement, what we say is the force of attraction between any two objects in general is called the gravitational force. It is not like only the force exerted by the earth. The force between any two objects present on the earth, that is gravitational force. Next, you have the very important universal law of gravitation. So, you have studied about various laws, children, but with regard to this gravitational force also, you have a law called the universal law of gravitation. Why the term universal? Because it is universally accepted law. Hence, it is called universal law of gravitation. Means this law, in any part of the earth you go and perform also, it is applicable, it is true, it is evident. Hence, it is called universal law of gravitation. That also you can say. Every object in the universe attracts every other object with the force that is proportional to the product of their mass and inversely proportional to square of the distance between them. The force is along the line joining the centers of the two objects. Means, children, just now we studied that any object you consider, they exert force on each other. So let us consider two such bodies or objects A and B, and the distance from their centers I am measuring. From the center of this object A to the center of this object B, the distance, let us say, to be D, and mass of the first object B, capital letter M, and mass of the second body or object B, small letter m. A and B are two objects or bodies which are exerting force on each other. Mass of first object or body is capital M. Mass of the second object or body is small letter m. The distance between their centers, I am telling, from center to center, the distance between their centers is d. Why am I doing all this? Because to derive the formula for the gravitational constant, children. So this sentence you need to remember. Every object in the universe attracts every other object with a force that is proportional to the product of their masses. So just now we studied any object you consider it is exerting force on each other. So and it is directly proportional to the product of their masses. Andre mass of A into mass of B, product M into M. F is proportional to M into M, but same time the force acting is inversely proportional to square of the distance between them. And what is the distance between these two objects? D, center distance D ಇದೆ. So inversely proportional andre it is 1 by anta. Directly proportional andre directly you will write. Inversely proportional 1 by. So it is inversely proportional to not only distance but square of the distance andre 1 by d square. So the force of attraction between these two objects A and B is directly proportional to product of their masses. The sentence what they have given, children, we are putting it in the mathematical form. The force of attraction between any two objects is directly proportional to product of their masses and inversely proportional to square of the distance between them. Call this as equation 1, call this as equation 2. So when you equate equations 1 and 2, you see that F is now proportional to, numeratorily we have product of the M into M divided by D square. Didn't we get so? What is capital M into small letter m? It is the product of their masses which is directly proportional to force divided by d square. Why? Because force is inversely proportional to square of the distance between them. So next step we need to remove this proportionality symbol. So in order to remove the proportionality symbol, the condition we should put equal to sign and introduce a constant and write the remaining terms m into m by d square as it is. So I introduced a constant. What is that constant, Andra? It is capital letter G, children. It is called gravitational constant. It is called gravitational constant represented by capital letter G. So this is a small 3-step derivation what is there in your textbook. Just you will say any two objects of mass m and m or m1, m2 if you want also you can take. And the distance between their centers is taken as d. Force is directly proportional to product of mass, inversely proportional to square of distance, then equal and introduce constant in order to remove the proportionality symbol. The constant is called the gravitational constant G and it has some value. Let us see what it is. Before that, let us just go through the derivation once. The same picture you can see what I have drawn. Distance between their centers is d. So let the two objects A and B of mass m and m lie at a distance d from each other as shown in the figure. Let the force of attraction between the two objects be F. According to the universal law of gravitation, the force between the two objects is directly proportional to the product of their masses. That is F is equal to m into m. They have called it as equation 10.1. And the force between the two objects is inversely proportional to square of the between them, and F is proportional to 1 by d square. Combining these two equations, what do we get is F is proportional to m into m by d square, or F is equal to G into m by d square, where G is the constant of proportionality and is called universal gravitational constant. I simply said gravitational constant, children. It is also called universal gravitational constant. G is the universal gravitational constant. By multiplying crosswise gives. So now what we got the formula is F is equal to G into m by d square. But what will be G? Just rearrange the terms in the formula. What do we get? Next is the question. By rearranging the terms of this formula and writing expression for what G is, children, LHS we have F I will write as it is, and I want only G here on the RHS. So divided by D square, if I send to LHS, I should obviously multiply it. So F into D square, and M into M, if I send to other side, division is there, means again I should multiply. Capital M into small m is equal to G, or we always have in the formula the term on the LHS, children. So G is equal to F into D square divided by M into M is the formula for the universal gravitational constant capital G. In the page 134 you have given the formula. G is equal to F into D square divided by M into M. The SI unit of G can be obtained by substituting the units of force, distance and mass in equation 10.5. So what is the unit of this gravitational constant andre? What is the unit of force? Newton. What is the unit of distance? It is measured in terms of meter. So D square andre, it is clearly meter square, divided by mass into mass. Unit of mass is kg. Again both capital M, small letter m, it is kg only. So nm square by kg square, or if you take kg square to the numerator, nm square kg power minus 2, it will become law of exponents. G unit of SI unit of G is Newton meter square per kg square. Either you can write kg power minus 2 or per, the slash you can put and write kg square. Don't write both, that is wrong. So Newton meter square kg square per kg square is the SI unit of the gravitational constant G. The value of G was found by Henry Cavendish by using a sensitive balance. The accepted value of G is 6.673. This is very important for solving problems, children. 6.673 into 10 to the power minus 11 Newton meter square per kg square is the value, standard value of G. The derivation you don't have, you will have to remember the standard value of G, that is 6.673 into 10 to the power minus 11 Newton meter square per kg square is the value of gravitational constant G, children. This was found by Henry Cavendish. This also you remember. We know that there exists a force of attraction between any two objects. Compute the value of this force between you and your friend sitting close by. Conclude how would you not experience this force. Yes, you can do it. Give it a try with your friend. The law is universal in the sense that it is applicable to all bodies, whether all bodies are big or small, whether they are celestial or terrestrial. I said no, universal means on the earth, wherever you go and do the experiment, you will get the result. That is universally accepted. Inverse square time, they have explained that you can